Welcome to This Explainer. Today, we're initiating a diagnostic scan of human psychology to uncover the hidden forces that literally program our social behaviors. We often walk through life assuming we're these entirely independent operators, making free choices based on our own personal logic. But decades of fascinating psychological research tell a completely different story. So, let's look under the hood of human interaction, shall we?
We'll be tracing this programming through 5 system modules: the social mind, internal conflict, the power of conformity, obeying authority, and finally, group dynamics.
Module 1, the social mind.
So, before we can interact with a broader network, our individual brain has to process the nodes around us. This happens through social cognition. It's basically the vital internal processing that helps us understand, predict, and form rapid judgments about ourselves and others so we can safely navigate our social world. And honestly, making these judgments quickly and accurately is absolutely crucial. Think about it. If we can figure out why someone is angry, we can react to resolve the problem. Our brains are just constantly running this background code, forming impressions based on physical features, behaviors, and social situations, which allows us to interact appropriately.
Module 2, internal conflict. But what exactly happens when our internal data conflicts with our external behaviors? Well, you get a system error. And this brilliantly illustrates cognitive dissonance. Discovered by Leon Festinger, this is an uncomfortable psychological polarization, a real friction that forces the brain to rationalize and actually change its attitudes to resolve the conflict. It's that very real discomfort we experience when our actions just don't align with our morals or our self-image. Like if we waste our time or hurt someone's feelings, we feel that negative friction. So to clear the error, the brain does something pretty amazing. It rationalizes. If you buy a hugely expensive gadget you definitely didn't need, you suddenly convince yourself its obscure features are completely life-changing. We're essentially reprogramming our own attitudes to match the behavior we've already committed to, just to escape feeling bad about ourselves. Crazy, right?
Module 3, the power of conformity. Now, when we start syncing our individual minds with a network of peers, things get a whole lot more complicated. You might naturally assume your visual sensors are totally objective, but Solomon Asch's famous line matching studies force us to ask a really crucial question about our reality. Do we always trust our own eyes? Back in 1955, Asch put a participant in a room with a group of people who were actually working for the experimenter. They were asked a simple, unambiguous question: which of 3 lines matches a standard line? For the first few rounds, everyone answered correctly. But then, the group purposely began giving the exact same wrong answer. The real participant was suddenly forced to choose, state the obvious, undeniable truth, or conform to the network's totally wrong answer. Incredibly, a staggering 76% of men in Asch's study gave at least one clearly incorrect visual judgment just to fit in with the group. Overall, 37% of all responses were conforming. They literally abandoned their own clear visual data to sync with the group. This perfectly highlights what we call normative conformity. We conform not necessarily because we actually believe the group is right, but simply because we want to be accepted and avoid standing out. It's a real game changer when you realize how much influence the group has.
Module 4, obeying authority.
So peer pressure is powerful, for sure. But what happens when a high-status authority issues a direct system override? Following World War II, psychologists were desperate to understand how ordinary people could be ordered to cause immense harm to others. Stanley Milgram used a menacing shock apparatus to test if everyday people would administer lethal voltages to a stranger simply because a scientist in a lab coat commanded them to. The setup was a total deception. The participant was the teacher, and an actor was the learner in another room. Each time the learner got a question wrong, the teacher was instructed to press a switch on the machine, supposedly delivering increasingly painful shocks, all the way up to a terrifying 450 volts marked danger, severe shock. Even as the actor screamed in fake pain and eventually went dead silent, the authority figure simply said, "The experiment requires that you continue." And here is the crucial point, highlighted by a frankly terrifying metric. 65% of participants delivered the maximum 450-volt shock. Let that sink in. Well over half the participants, as far as they knew, had shocked another human being to death. But here is the absolute most important takeaway from Milgram's data. This does not prove that people are innately evil. What it proves is that the social situation, the commanding presence of authority, is so incredibly powerful that it can drive extreme compliance, completely overriding our own moral coding.
However, it's not all doom and gloom because this obedience programming can be hacked. When Milgram tweaked the situation, the data changed dramatically. Compliance dropped significantly if the subject could choose their own shock level, if the authority figure communicated remotely by phone instead of standing right over them, or, and this is key, if other peers in the room refused to participate. When we see others rebel against bad code, it frees us to do the exact same thing.
Module 5, Group Dynamics.
Finally, let's zoom out a bit to analyze the processing power and the potential system bugs of large network clusters working together. When we join groups, we face a mix of benefits and costs. The concept of social facilitation, mapped out by Robert Zions, shows how the physiological arousal of having an audience influences our performance. See, when you're around others, you naturally experience arousal. This arousal increases the likelihood of your dominant response, basically the action you're most naturally inclined to do. If it's a simple, well-learned task like riding a bike, the dominant response is usually correct, and the audience actually enhances your performance. But if it's a complex or new task, the dominant response is often incorrect. This causes a system failure where your performance actually drops just because people are watching.
But groups also suffer from process loss, specifically a very common bug called social loafing. Have you ever noticed that in a group project, not everyone pulls their weight? Yeah, we've all been there. Social loafing is exactly that. It's a group process loss where individuals exert significantly less effort in a collective than they do when they're working alone and their individual output is actually being measured.
Ringelmann's historical rope-pulling data perfectly visualizes this efficiency drop. I mean, you'd logically expect 8 men to pull 8 times as hard as 1, but the data clearly shows that a group of 8 pulls at only 37% of their actual combined capability. Because individual effort is hidden within the group, people unconsciously let the network carry the load.
So how do we fix this? To patch these network vulnerabilities and prevent issues like social loafing or groupthink, which is where members just blindly conform to bad ideas to maintain harmony, we absolutely have to optimize coordination. The research shows we need to keep group sizes small, ensure rewards are distributed equitably based on effort, and most importantly, maintain individual accountability so no one's contribution gets lost in the aggregate data. As our diagnostic scan concludes today, we've seen just how deeply the social situation programs us. From rationalizing our own cognitive dissonance, to conforming to a crowd's obvious errors, to obeying terrifying authority. This incredible psychological data leaves us with one highly provocative thought. The next time you make a social decision, how much of your behavior is truly yours and how much is just the network running its code? Thanks for joining me on this explainer. Keep questioning the system.